Okay. So parallel and perpendicular lines. What does parallel mean? Show me with your arms. What does parallel mean? Okay, that means they never ever touch. You can do it this way, you can do it this way. What does perpendicular mean? Okay, is this perpendicular?
Yes. No, yes, because they're crossing.
Why is this why is this not perpendicular?
It's not a right angle.
Yeah. Perpendicular lines make 4 90-degree angles, 4 right angles. So, like this. Okay. If you want to write this at the top of your paper, you can use this this symbol right here. This means perpendicular. And this symbol means parallel. On some of these questions, you're going to have to write out like a sentence or two. So if you want to use those symbols to abbreviate a little bit, that's okay. Just don't mix up your symbols. But they make sense because this one has 90-degree angles. This one, they're parallel. Okay, so first we're going to talk about parallel lines. This first sentence right here is very important. Parallel lines have the same slope. Okay, the exact same slope. Remember, slope is talking about like how steep something is. So if they have the same slope, then they're the same amount of the same steepness. What's the word I should use? The same incline? Incline. Yeah. Perfect. Okay. Steepness. So they have the same slope. But perpendicular, they're not going to have the same slope. So right here it says you can write an equation of a line parallel to a given line if you know a point on the line and an equation for the given line. Okay, so example 1. It says write an equation in slope-intercept form for the line that passes through negative 4, 1 and is parallel to the graph of y equals x plus 4. This says a lot of important stuff. First, you see it says write the equation in slope-intercept form. This is your final answer, needs to be in slope-intercept form. So what is that?
Y equals mx plus b.
Good. Okay, and then it also says parallel. So parallel tells me that they have to have the same slope. So starting off, what you want to do is you want to look at this equation and see, can I pick out the slope from this equation? So in order to pick out the slope, it's got to be in slope-intercept form. So the slope is right here. That's your m. Your slope should be 1. Okay, the number in front of your x. So, y'all remember point slope form? That's what we did last Monday and Tuesday. Y minus y1. Yeah. Yeah. Yep, right here. Equals m times x minus x1. So we can use the information that we have. We know the slope has to be 1 because it's got to be the same slope as this other equation. And x1 and y1, those are going to come from the ordered pair that they give us. x1 is negative 4, y1 is 1. And then we plug those into this equation. So if you remember, it says write an equation in slope-intercept form. That means we've got to change this to slope-intercept form. That means we have to isolate the y. Okay, any questions so far? So if two lines are parallel, they have the same slope. Okay, so look down here. So write an equation in slope-intercept form for the line that passes through -3, 5 and is parallel to the graph of y equals 2x minus 4. So first, look at this and pick out what is the slope. 2. Sometimes this equation is going to be already in slope-intercept form, sometimes it's not. So if it is not in slope-intercept form, that means you've got to get it there so you can look and see what is m. Okay, now x1 and y1, they come from this ordered pair. And then I'm plugging that into point slope form. So I have y minus 5 is equal to 2 times x minus -3, or I can write plus 3. So this really goes back to what we did last week. How do I go from point slope to slope intercept? There's two things I need to do. Micah? Well, it's almost like we're just kind of like going to rearrange this equation. So, getting it in slope-intercept form, what we focus on is getting this y by itself. The first thing you need to do is distribute this. What do I do after I distribute in order to get this y by itself? Add 5. So y is equal to 2x plus 11. And this now is in slope-intercept form. So this is my answer. Okay, any questions on that one? Go to the next page. Alright, now we're going to talk about perpendicular. So perpendicular lines do not have the same slope. Their slopes are actually opposite reciprocals. What is a reciprocal? Elise? Yeah, like what's the reciprocal to 1/4? 4 over 1 or just 4? Okay, what's the reciprocal to 2/3? 3 over 2 or 3/2. Okay, so when it says reciprocal, this tells me just basically flip. What about opposite? Opposite isn't the same as reciprocal. When it says opposite, yeah, it has to do with the sign. That means like if it's positive or negative. Okay, so not just reciprocal, it's opposite reciprocal. Like for example, right here, what is the slope to this line? It's right here. The m is -1/3. And the slope to this line is 3. So you see, these are not just reciprocals. They're opposite reciprocals because one is negative and one is positive. Okay, so you can use slope to determine if two lines are perpendicular. Okay, or you can use like the slope formula a lot of the times to help you. Okay, so it says on the plans for a treehouse, a beam represented by QR has endpoints Q is -6, 2, and R is -1, 8. A connecting beam line ST has endpoints S -3, 6, and T -8, 5. Are the beams perpendicular? Okay, so to figure this out, you're going to have to use the slope formula. First, look at points Q and R. Q, we have -6, 2, and R, we have -1, 8. So we used those in the slope formula and got 6/5. And then ST, we use -3, 6, and -8, 5. And when we use those in the slope formula, we get 1/5. In order for these lines to have been perpendicular, like if the slope of QR is 6/5, what would the slope of ST have to be? -5/6. Not just 5/6. We're forgetting that opposite part. Okay, so the beams are not perpendicular because these are not opposite reciprocals. Okay, so a similar question right here in this practice, but instead of giving you ordered pairs, it's giving you equations. But we still have to look at the slopes. It says determine whether the graphs of these three equations are parallel or perpendicular. To do this, you need to get all equations in slope-intercept form. Okay, so my equations are 3x plus y is equal to 12, y equals 1/3 x plus 2, and 2x minus 6y equals -5. Which one of these equations is already in slope-intercept form? The middle one. Okay, so we know that this one is good to go. Now, we need to get the first one and the third one in slope-intercept form, or isolate the y to be able to tell what is the slope. Okay, go ahead and try to do that on your own. You need to talk with the people in your group. If you're not sure what to do, that's okay. Okay, so the first one, to get it in slope-intercept form, what do I need to do? Good. So y is equal to, make sure you write the term with the x first, negative 3x plus 12. So in this problem, m is equal to negative 3. Okay, the next one, I need to get the y by itself. I start by subtracting 2x. So negative 6y is equal to negative 2x minus 5. I've got to get rid of this negative 6. It's not all the way in slope-intercept form until the y is 100% by itself. I divide every term by negative 6. So y is equal to, I'm not going to write negative 2 over negative 6. I want to simplify this to 1/3. And 2 negatives make it positive. 5, 6. Okay, so in this problem, the slope is 1/3. So I'm actually going to have to write a sentence and saying the relationship between these two. Who can tell me which lines are perpendicular? Okay, which ones are perpendicular? Jamie? Yeah, the first one is perpendicular to both the second and the third. So we want to write that, and you can write the first and second and third. You can write it that way. So I'm going to write the first equation. You can use your sign for perpendicular. Is perpendicular to the second and third equation. Okay, and then which ones are parallel? Xander? Yes. Tania, did you have a question? Give me 1 second. Five, 6 right here. So, do you understand this part? Oh, I got negative 5 right here. So, it's negative 5 divided by negative 6. So, because it was a negative and a negative, it became positive. And I can't do 5 divided by 6 and get a whole number. So, I just wrote this fraction right here. 5, 6. Does that answer your question? Okay, any questions on this problem? It kind of takes a few minutes to do, but it's not that bad. Alright, the last example, we're going to be writing equations that are perpendicular to another equation. It says, write an equation in slope-intercept form for the line that passes through negative 3, 4 and is perpendicular to the graph 9x minus 6y equals 3. The very first thing you've got to do is look at this equation right here and figure out what is the slope, what is m. So to do that, you're going to need to get this equation in slope-intercept form. So this is already done for you. We subtract 9x and then divide by negative 6. So you can see that the slope is 3 over 2. So these are perpendicular, so that means the slope to the line that's perpendicular is the opposite reciprocal. That is where this negative 2/3 came from. We flipped it and made it negative. So from there, it's just like the other ones. We use our new slope of negative 2/3. And then x1 is going to be negative 3 from the ordered pair. y1 will be 4 from the ordered pair. And we've got to get to the equation in slope-intercept form. Wilson?
Will x1 always be negative?
No. x1 is, it comes from this order, like the ordered pair that it gives you. So this first number is x1. That one. So no, it's just a coincidence. Okay, so this practice problem, I kind of want you to do a little bit at a time. The first thing that I want you to do is get this equation in slope-intercept form. Does everybody think they can do that? Get this equation in slope-intercept form, so solve for the y. On these, keep in mind that you're going to have to find the reciprocal. So, are decimals a good idea? No, because you're going to have to flip. You don't want it to be decimal. And do you want it to be like a mixed number? Not really. You don't want that either. You just leave it improper and make sure you leave it as a fraction. Okay, so slope-intercept form. I subtract 7x. I get negative 2y is equal to negative 7x plus 3. And then divide by negative 2. So y is equal to, both of these negatives cancel out. Get positive 7 over 2 x minus 3 over 2. Taylor? Like putting these two together? Oh, like right here, you're doing 3 minus 7x equals negative 4x. So the reason we can't do that is because this has an x and this one doesn't. So you can't put them together. You just want to write the term with the x first and then write the one that doesn't have an x. So what is the slope for this equation? 7 over 2. So for my new equation for the line that's perpendicular, what does it need to be? Good. Negative 2 over 7. Opposite reciprocal. And then we have x1, y1. So x1 and y1 come from the ordered pair. x1 is 4. y1 is negative 1. And we're plugging that into point slope form. So I have y minus negative 1 or plus 1 equals negative 2 over 7 times x minus 4. Now you want to get that into slope-intercept form. So this is negative 2/7 times negative 4. I don't need my calculator. I'm just multiplying the numerators. Negative 2 times negative 4 is 8 over 7. And now we subtract 1. So y is equal to negative 2/7 x, 8/7 minus 1, or minus 7 over 7. Is 1/7. Okay, any questions on that? Tonight?
So for like 175 equals 7.